Hi, welcome to Mrs. Park's Algebra 1 class. This is 5-6, graphing inequalities in two variables. So far we've been doing inequalities by adding, subtracting, or multiplying, dividing, and we also tried the combination with multi-step inequalities. Now we're going to move on to solving graphing inequalities with two variables. That means we'll probably have a y and an x in it. Alright, so what is it going to look like? Graph linear inequalities. The graph of a linear inequality is a set of 2 points that represent all of the possible solutions of that inequality. So basically what it's going to look like is you have y equals mx plus b that we're used to. So it's going to be that kind of line here that you see, but instead it's going to be shaded. So depending on if it's greater or less than, or greater or equal to, or less or equal to, there's going to be part of this graph that's shaded. So let's see here. An equation defines a boundary which divides the coordinate plane into two half planes. So you see here, this is the equation that they have, and it divided into two half planes, and this upper portion is what they're shading. The boundary may or may not be included in the graph of an inequality. When it is included, the solution is a closed half plane. When not included, the solution is a open half plane. Okay, so here's the 3 steps that you need to know in order to graph these linear inequalities. Graph the boundary. That means, if it has mx plus b, that's great. Just graph it as you normally would. Then you would use a solid line when the inequality contains greater or less or equal to, or greater or equal to. So there's going to be one difference is when you graph this equation, when you graph this line, it's going to have that equal sign. That means it's a solid line. If it doesn't have that equal sign on the below, it's going to be a dashed line. That's going to have just dots going through. Step 2, use a test point to determine which half plane should be shaded. And this will make more sense when we do a sample together. Step 3, shade the half plane that contains the solution. Okay, it's going to make a little bit more sense, much better sense when we solve this together. So, graph an inequality. Here's a graph, 3x minus y is less than 2. So how do we do this? First thing you're going to do is you are going to solve so that it looks like y equals mx plus b. That's what we're used to doing when we're graphing. Oops. So here it is. You have 3x minus y is less than 2. So what they did was subtract 3 on each side, 3x on each side. Whoops. And then they subtracted 3x on this side. So that was gone. You have negative y is less than negative 3x plus 2. In order to get rid of that negative, we did divide by negative on each side. Now remember, when we divide by a negative number, this sign, it flips to the other side. So now you have y is greater than 3x minus 2. So all we did was, from this, we made it into that, which is easier when we have y equals mx plus b. This time it's y is greater than mx plus b. So that we know how to graph. And that graph will look like this. You remember, you start with the negative 2, because that is the y-intercept. So this is what they did here, negative 2. What's that one I read? So there's your negative 2. Remember how we graphed this? And then rise over run. This 3, the slope is 3. So rise 3, 1, 2, 3, run 1. And there's your other dot, connected to dots, and there's your line. So notice this is not a solid line, it is a dashed line. That's because it's greater than. If it had a greater or equal to, if at that line equal to sign at the bottom, then it would be a solid line. That's the difference between the dash and the solid, if you have a or equal to sign below this inequality or not. So here's your graph. Step 2 was select a test point in either a half plane. A simple choice is 0, 0. So a lot of these you can just use 0, 0. So if you put in 0, 0, okay, for x and y, then you have 3 times 0 minus 0, which is 0. So 0 is less than 2. If this is true, that means it's going to include that testing point 0, 0. So they shaded in everything to the left of this equation here. Okay, so y is greater than 3x minus 2. Here's your graph, and this is the shaded portion. So the half plane containing the origin is a solution. Shade this half plane on the left. Another way I like to think about this is where it meets on the y-intercept right here, it's greater. So I want to think about greater as being the upper portion. So anything upper portion of that is the left side of it. Okay. So I like to think of the y-intercept as a point where you say greater is up, less than is lower. Or you can use this method I use here in the textbook. You can do a test point, usually 0, 0, and see if that's true. If it is true, then you will include that part as well. Okay, so at this point, I think it is time for your turn. So make sure you pause this video, do your turn numbers 1 and 2. I will provide you with graph paper. Hopefully I gave it to you already. Make sure you graph them on your graphing paper. Make sure you label it numbers 1 and 2. Put your name on it and come back when you're done. Okay, welcome back. Here is example 2 we're going to be working on. Now here is an example of when you have an inequality that has the equal sign on the bottom. So you notice right away in the graph, it's a solid line. It's not a dashed line. Okay, that's a big difference. If it has an equal sign on the bottom, it's a solid line. If it does not, it's a dashed line. Okay, same thing we're going to do is take the same 1, 2, 3 steps. You're going to solve for y to make sure it looks like y equals mx plus b, but in this case y is less or equal to mx plus b. So what they did here was subtract the x on each side and then divide it by 5 on each side. And what they came up with, here's the equation. So you're to graph this, and this is the previous skills that we learned on how to graph linear equations. You start with the y-intercept, which is a positive 2 here. Put a dot. Ooh, excuse me. From that point, you rise 1, run 5 to the left. So rise 1, run 5, 1, 2, 3, 4, 5 to the left because it's a negative, and that's your other point. Whoops. And you connect the 2 dots, and there's your nice solid line. Okay, again, it's a solid line because it has that or equal to on the bottom. All right, so second part, you're going to do a test point. When you have a point, usually you want to use 0, 0. So when you have 0, 0, substitute x and y with 0 and 0. So here we go. We have, they used the original equation. They put 0 plus 5 times 0 will be, of course, 0. So 0, 0 is less or equal to 10. So here you can use, you know that the part that's including the 0, 0 is the part that's going to be shaded. This, in the textbook, they use 3, 3. It doesn't matter which point you use, because if you had 3, 3, this would not be true. 3 plus 5 times 3 is 18, and that's not less or equal to 10, so it's not going to include that point, so the other side. So, or you can also do how I showed you before, y is less or equal to. So where that y-intercept is, it's going to be less. That means the bottom portion. So shade in that whole portion, and that's your graph right there. Okay, so I believe, next slide. Your turn, numbers 3 and 4. Pause the video. Make sure you graph those two. Make sure you label them 3 and 4. If you did numbers 1 and 2 in the front page of the graphing paper, make sure you use the back to do numbers 3 and 4. Okay, so here is an example 3. Solve inequalities from graphs. Okay, so we're going to do the same thing here. We're going to solve for x, and they took away 5 on each side and then divided by 3, which gave you x equals 3. So this time, this graph, x equals 3, is this graph here. It's 1, 2, 3. That's what x equals 3 looks like, a straight line going up and down. You notice it's a dashed line because it has less than sign. Now, same thing, you're going to test. I normally would use 0, 0. So 0, 0, if you put it in here, 3 times 0, 0 plus 5 is 5. 5 is less than 14? Yes, absolutely. So that means the part that's containing the 0, 0 is the one that's going to be shaded. So it's the left portion. Now when you shade these, you're going to just simply show me that which side is shaded by doing this. Okay, because I don't want you coloring the whole graph in like that, like it looks like in the textbook. Okay. Here is your turn, numbers 5 and 6. So put this on a separate sheet of graph paper, numbers 5 and 6. Okay, and that is the end of the video. Make sure you turn in your homework tomorrow for full credit. Thanks for watching.